Good. Today we'll have a small discussion on magnetic field due to a current element in which it is called Biot Savart's law. Biot and Savart observed whenever current flows in a wire, consider wire as use wire just to take a small part of it. It is called X and Y, the strip, and current flows in this direction. Consider small element dl where current is I. The together it is called current element. This current element, ideal, gives rise to a magnetic field at a distance r. What is the magnetic field here? The magnetic field is taken as dB. It is called elemental small field. Means this magnetic field is entering into the plane of a paper. Now this magnetic field, dB, this magnetic field, dB is directly proportional to current element. Current element means I dl and inversely proportional to r square. So of course, what I mean to say, the current which is flowing in a wire gives rise to magnetic field surrounding it. What is the magnetic field at a distance? R. The magnetic field, this elemental magnetic field is directly proportional to the current element and it is r square dependence. But what we have noticed, when I write it, this magnetic field is a vector physical quantity. I'll be writing in this fashion. This magnetic field dB, which is directly proportional to I, it's a cross product, I dl cross r, and again inversely proportional to, of course, we write in this fashion in the denominator r cube to satisfy the mathematics because it's r square dependence or already taken. This is going to be a vector. Now to remove it, I'll write magnetic field is equivalent to mu 0 upon 4 pi into I dl cross r bar in the denominator r cube. This is going to be a Biot Savart's law. This equation is called Biot Savart law, where the magnetic field is again perpendicular to the plane containing current. See here, if this is a plane, this vector, radial vector, is in the plane and this current element is also in the plane, whereas your magnetic field is perpendicular to the plane. So in that fashion, if I take this x, yes, let me take this as x and y are in the plane, and x-axis and y-axis it is I. So it is y cross x. Y cross x is minus z because y means ideal. Ideal is y. This is called I dl cross r. If ideal is y direction is given by ideal current element, and x is r direction, and the direction of the magnetic field is in this direction into the plane. It is called plus z. This is minus z. So this convinces us the fact that magnetic field due to current carrying wire gives rise to magnetic field which is mutually perpendicular to both the current element and the radial vector. We derived a small relation that is directly proportional relation, that is magnetic field is given by magnetic field due to a current carrying element dB is given by, you can put it in this fashion, it is given by mu 0 divided by 4 pi I dl r square sine theta. Call it as equation 1. Similarly, electric field, we know electric field E equal to 1 upon 4 pi epsilon 0 q divided by r square. Call it as equation 2. Equation 1 and equation 2. Equation 1 is magnetic field. Equation 2 is electric field. The first similarity, magnetic field and electric field, both, it is called, both are inverse square dependence. Inverse square, that is 1 upon r square dependence. Second one, magnetic field means B, this magnetic field B, it depends on ideal, whereas a vector source. Whereas electric field depends on charge, it is a scalar. Means magnetic field results due to a vector source, electric field results due to a scalar source. The source is scalar in nature. Next, the direction of the magnetic field, is perpendicular to the source, perpendicular to ideal and R. Whereas electric field is along the line joining, along the joining source point and field point. I hope things are very clear. Magnetic field direction is perpendicular to the source element and the radial vector, whereas electric field is along the line joining the source and the field point. The fourth point is the last. Of course, we noticed a small parameter. This magnetic field is 0 if ideal and R are in same direction. Whereas that is not in case of electric field. Electric field, if it is a positive, it is radially outward. Electric field, if it is negative, it is radially inward. In case of magnetic field is 0 if this ideal and R, if this ideal and R are parallel or anti-parallel. If ideal R is parallel means theta equal to 0 and anti-parallel means opposite, hence there will be no magnetic field. This means for theta equal to 0 and theta equal to 180 degree. For theta equal to 0 and 180 degree, your magnetic field is going to be 0. We know that epsilon naught is a permeability of air and mu naught, yes, let me write it. Epsilon 0 permittivity of air and mu 0 permeability of air. This air being a medium, it has two properties. Due to charge, we call this is due to a magnetic source. This magnetic source can be moving charges or it can be a current. It can be current or moving charges. Yes. Now the product of these two means epsilon 0 mu naught. Let me rewrite in this fashion. You can multiply 4 pi epsilon naught into 1 upon mu naught. Let me write it here. Mu naught 4 pi. This product epsilon 0 mu naught is equal to, let me write, equal to 4 pi nullifies. This is a value. You can put it a bracket. And we know that this value, we know that 1 upon 4 pi epsilon 0 is equal to 9 into 10 raised to plus 9. If this is the case, it becomes inverse 1 upon 9 into 10 raised to plus 9, this whole equation, into this already written 10 raised to minus 7. Yes. When I do this mathematics, you can notice it is 4 pi epsilon 0 is this, mu 0 upon 4 pi is 10 raised to minus 7. Simplification will give you me 1 by 3 into 10 raised to, it is 9. Now this value becomes 9 and 7 becomes minus 16. So this quantity, it is minus because plus 9 becomes minus 9. This is the value, and you have the product epsilon 0 mu 0. Now, this value is typically, it is actually 3 square. Let me write it, it is 9. 9 means you can have 3 square. So once I rearrange it, it becomes very simple quantity. Now this 3 square comes this side, and this whole analysis further I will write it. It is 1 upon 9 into 10 raised to 16. Or I can say epsilon 0 mu 0 is equivalent to 1 upon 3 square into 10 raised to 8 or whole bracket square. This, check it out, this 9 means 3 square means 3 square, 16 means 8. So finally I can put it in this fashion, epsilon 0 mu 0 equal to 1 upon c square. Or I can write it c square equal to 1 upon mu 0 epsilon 0. Further I can write c equal to 1 upon under root mu 0 epsilon 0. So this formula is often used in the chapter. Look at this relation. Epsilon 0 is a permittivity of air, the product 4 pi nullifies, epsilon 0 mu 0. 1 upon 4 pi, 9 into 10 raised to 9. 1 upon 4 pi epsilon naught is 9. It becomes invert. So 4 pi epsilon 0 is 1 upon 9 into 10 raised to plus 9. And this mu 0 upon 4 pi is 10 raised to minus 7. The simplification gives you plus 9. If you bring it down, it becomes minus 16, or you take it out as it is. Both are one and the same. This product, epsilon 0 mu 0, will give me 1 upon 3 square into 16. So something like epsilon 0 mu 0 is 1 upon c square, which is equal to c square comes here. Finally, c square equal to 1 upon the product of mu 0, epsilon 0, permeability and permittivity. Then finally, c is the velocity of light. Do remember, c is very interesting property. C, velocity of light.